Let's begin. Today is August 2nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 6, 11, 18, 19, 20, and 22. And the puzzle uses the blue verification cards. The code above is your way to find out more information on today's puzzle by searching it on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our middle digit, the square digit, and the Turing Machine will let us know whether its value is even or odd. Criteria card B will take a look at our first 2 digits, triangle and square, and compare them. So should the value of triangle be less than square? Should they be equal? Or should the value for triangle be greater than square? Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them together, and will let us know whether the sum is an even quantity or an odd quantity. Criteria card D again looks at our first 2 digits, triangle and square, add them up, but this time compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E will take a look at our 3-digit solution and will let us know a little bit about what the digits are, meaning are there any repetitions, or basically are there no repetitions, meaning they're all unique, as in the example 1, 2, 5, or potentially it could be a double number where there's a repeating digit, as in the example 1, 1, 2, or it could even be a triple number where it's the same digit repeated 3 times, as in the example 2, 2, 2. And finally, criteria card F again looks at our 3-digit solution, but this time will let us know a little bit about its ordering from triangle to square to circle. Should the digits be in an ascending order, meaning that they're increasing, as in the example 1, 3, 5, or are they descending, or basically decreasing, as in the example 4, 2, 1, or potentially even it may have no order. Notice that in the example, it goes from 2 to 3, so it increases, but then it goes from 3 to 1, or decreases. That's one way that you can define no order, that shift from increasing to decreasing. There have also been cases where if any 2 digits, consecutive digits in the solution are equal, that fact that it doesn't change is another way to define no order. And of course, the objective of today's puzzle is to find that one unique 3-digit code that abides by all of the 6 criteria cards we just discussed. Now let's start off with an initial proposal of 314. So the first thing I want to test is I want to learn a little bit more about that middle digit, the square digit. So let me go ahead and test criteria card A. Okay, so the Turing Machine does not approve of what I have for square. I did choose an odd 1. Since it does not approve, it's basically telling me that square should be an even digit. So let's go ahead and type that up in the notes here in section A, that square is an even digit. And since it is an even digit, let's go ahead and cross out all the odds for square. So crossing out 1, 3, and 5. Next, I'd like to test criteria card C to know a little bit about the sum of the 3 digits. So let's go ahead and test that. Okay, so in this case, the Turing Machine does approve. Since we're adding all the digits, let's go ahead and add up. 3 and 1 gives us 4. 4 and 4 gives us a total sum of 8. So yes, the Turing Machine is letting us know that the sum of the 3 digits is indeed even. So let's go ahead and type that up in our notes in section C. So triangle plus square plus circle must be an even quantity. And because it is even, notice that we already established that square is even. So that means that the sum of triangle and circle must also be even. So there are two scenarios. Either triangle and circle are both odd, because the sum of two odds is even, or all three of them are even. So in either case, whether it's we have two odds or two evens for triangle and circle, both will give us an overall sum of even. And we could test criteria card E to see whether there may be a pair of digits or no repetitions. So let's go ahead and test criteria card E. Okay, so notice that it does approve of my proposal, and I do have all distinct digits. So that's what we'll write down. We'll say that there should be no repetitions in our solution. So let's go ahead and type that up in our notes for section E, that the solution has no repetitions. And because there are no repetitions, again, as a reminder, square is already even. So that means that triangle and circle cannot be even, because if they were, then at least one of the evens would be paired up. So we can actually say that, let's see, where would be a good place? I guess maybe here, since we already know that square is even, we can say that triangle and circle are odd. Okay, and since they are odd, well, let's go ahead and cross out 2 and 4 for both. So neither can be 2 or 4. And so basically we have kind of a structure of odd, even, odd in our solution. Okay, well, that does it for this round. We've already completed our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, the comparison of square, triangle, and square, nor the addition of those two digits and comparing that to 6, and whether there could be no order or some sense of either ascending or descending. Well, since we know that triangle and square are odd even, we know that the sum cannot be 6, right? Because whenever you add an odd and an even, you're going to get an odd value. And so I think you equally have, let's see, do we have an equal amount of less than 6 and greater than 6? So 1 and 2 and 1 and 4 will give us less than 6. 3 and 2 gives us less than 6. And then, of course, 3, 4 and 5, 2 and 5, 4 all give us greater than 6. So it is a sort of 50-50, right? Because we've already established that you can't have a sum of equal to 6. And similarly for criteria card B, they can't be equal to each other either. One's odd, the other is even. So let's see, how can we hedge our bets? Obviously we can pick a sum that's either less than 6 or greater than 6, and then criteria card B will let us know some sort of ordering. And notice that other than criteria card C, there is no direct reference to circle. So circle somehow is going to have to be forced into either 1, 3, or 5. We already know obviously it's odd, so somehow maybe the ordering, something like it could be ascending as in 1, 2, 3, 1, 2, 5, 1, 4, 5, and I'm sure there's similar cases of descending, and a great variety of no order. So let's see. How can we construct a good proposal that will sort of guarantee a solution towards the end of the second round? I'm really considering, would 3 help us for triangle? It seems to be, that middle digit that could tip us over to either, a less than 6 or a greater than 6. Let's see. Well, it seems like maybe the extremes, like 1 and 5, does that even make, yeah, it kind of makes sense, right? If you know triangle is 1, then of course it's going to be less than square, and vice versa if triangle is 5. Oh, here's an interesting scenario. Let's see. I think we can say that it's not going to be in an ascending order. Well, can we? Just because it's ascending doesn't guarantee. Well, let's see, is that true? If you say it's ascending, then yeah, you're guaranteed that triangle will be smaller than square. Absolutely. So I think for that reason it can be ascending, because you would know that fact and it would make criteria card B irrelevant. And I think the same, you can say the same thing about descending. If it's descending, then you absolutely know that square is bigger. Sorry, that triangle is bigger than square, because it'll be descending. So I think for that fact, I think we can deduce that it's going to have no order. And so how can we guarantee that? Now, it's not the same vice versa, right? You could have a triangle value that's smaller than square, but then the circle could decrease and that therefore give you no order. So I don't think you can use criteria card B to say somehow something about criteria card F. That said, again, it's just 50-50 whether the triangle value is going to be less than or greater than. So again, I'm trying to see what could I do to hedge my bets. Could it be something like 3, 2, 5? We know that there's no pairs, so the odd values are going to be distinct. Yeah, I just don't see anything that's foolproof. So let's go ahead and test 3, 2, 5 and see where that takes us. Okay, so first, let's see. Let's actually test criteria card D. I think that may give us more information. Okay, so it's true that the sum of the first 2 digits, triangle and square, should be less than 6. So let's put that in our notes for section D. We're going to state that again, triangle plus square should be less than 6. And let's see if we can eliminate something. So I think if the sum is to be less than 6, then obviously triangle cannot be a 5. I think we can say that much. And obviously 2 works for both the triangles, but if square root were to be 4, it would only work with 1. And I think we've already deduced that it's going to have no order. So let's go ahead and test. Let's see. Well, I think we can say that triangle can be 1. Because if triangle were 1, then both of these cases would be true for criteria card B. 1 is less than 2 and 1 is less than 4. But I guess, let's see, that would be true, and so would C and D and E. Now the repetition, so if it was 1, 2, it would have to be 3, 5, and again you wouldn't be able to distinguish 1, 2, 3, and 5 because there's nothing, there's nothing to distinguish 3 and 5. They're both increasing or ascending, but we already said it should be no order. And what about 1, 4? I guess with 1, 4, it could be 5 because that's the lone ascending. But we already said that it can't be ascending. And 1, 4, 3, 1, 4, 3 would work. 1, 4, 1 is not in play because you can't have pairs. So 1, 4, 3 could work. And then it would have to be 3, 2, 3, 2, 5, which is what I have. So it looks like we only have 2 possibilities, 1, 4, 3 and 3, 2, 5. So I think, if I test criteria card B, that should basically let me know which of the 2 is true. So let's go ahead and test B. Okay, so 3, 2, 5 also worked. And just to make sure, I do have triangle 3, square 2, so that means triangle is larger than square. So let me just add that to the notes in B. That triangle is greater than square. And just to cover our bases, let's see what we can eliminate. So we can eliminate the 1 because 1 is not bigger than either 2 or 4. So we can eliminate the 1, which makes it a 3, and that needs to be greater. So that means that square cannot be 4. Okay, so far it's making sense. It can't be a 3 because there's no duplicates. So we can cross out the 3, and then it boils down to either being 3, 2, 1 or 3, 2, 5. But as we stated, that we deduced that it should be no order. So let me go ahead and type that up. And again, the reason it's no order is that if I know it was ascending, I know that triangle would be less than square. And I know that if it was descending, it'd be the opposite, that triangle should be greater than square. And again, making this card irrelevant. So that leaves us with just one option for criteria card F, and that's no order. And so 3, 2, 5 looks like this. Well, let me actually eliminate the 1 since that is descending. And so it looks like 3, 2, 5 is our answer. So let's type it up. Okay, and let's go verify. So 3, 2, 5. Fantastic. Now let's see how we did versus the Turing machine. And we only tested 5 out of 6. So that deduction really helped out. So I'm very confident. And the only one that we got wrong was A. So we did ACE and then BD. So let's go type that up. So ACE and then BD. And we skipped F. How do we do? Okay, so we just beat it by one question, but that's still a great win. Again, this deduction I think really paid off. It could have been that one extra question that we did not have to do. And so what do you think? Any additional thoughts? Please add them to the comments. If you like the video, give it a thumbs up. And if you don't want to miss out on any future videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.